Good day, class. So today we will be performing experiment number 2 entitled vernier calipers. No? Now, what is a vernier caliper? A vernier caliper was a device invented by Perry Vernier, no? In 1631, and this this measuring equipment is used to measure small diameters of cylinders, either solid cylinder or a hollow cylinder. No? So today we will uh, study, or we will study how to read a vernier caliper. So this is a vernier caliper, and this vernier caliper is calibrated both in metric system and English system. No? So in the upper part of the vernier caliper, you have what we call the vernier scale in English system, and in the lower part here is called the vernier scale in the metric system. So the main frame of the vernier scale is calibrated into metric in the lower, in centimeters, and English in the upper part, which is in inches. So how to read this vernier caliper? So I have here a cylinder, and this cylinder, we are to determine the diameter of the cylinder by using the vernier caliper. Okay, so here you just push the jaw of the jaws of the vernier caliper, and therefore in that setting, this is the lock. In that setting, you can now read the observed diameter of the cylinder, both in metric and in English. No? So how do we read the scale in metric and in English? So I will show you here a illustration of how this vernier caliper can be read. Okay. So in the board, I have here an illustration of a vernier caliper reading. So the main frame here is the ruler scale. The lower is in centimeters, and we know that each centimeter is divided into 10 scales, no? 10 scales, 10 lines. So in the upper part of the ruler scale is the English system, which is in inches, and we know that per inch it is divided into 16 scales or 16 lines. Okay, so how do we read the vernier scale? Now, how do we read the vernier scale using the metric? Okay, so here this is the metric scale of the ruler, and below here is the vernier scale, no? Vernier scale. So in the vernier scale, there are 20 lines, no? There are 20 lines. Starting from this, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 lines. And each line of the vernier scale is equivalent to 0.005 centimeter. No? So ito pa, from 0 to this line, this distance is equivalent to 0.005 of a centimeter. So this is the vernier scale. So when you have, if we consider here, let's say 5 lines, so we count this 1, 2, 3, 4, 5. So there will be 5 lines. The reading of that 5 lines is equivalent to 5 times 0.005, or that is 0.025 centimeter. Okay, to start how to read the vernier, okay, the zero here, the first zero here at the left side is the pointer, no? This is the pointer. And this pointer here will point the reading on the roller scale. So for instance, this is 4 centimeters, then this is 4.1, 4.2, 4.3, 4.4. However, the pointer of the vernier scale is at 0.3 or just past 0.3, no? Just past 0.3 of this 4.3 centimeter. In other words, the roller scale already have a reading of 4.3, no? 4.3. That is the roller reading. And the second step here is to find the coincidence line. The coincidence line, it means that the line from the roller scale will coincide with the line of the vernier scale. No? So, for instance, here you will find the coincident line starting from 0. So, we found out that this line here of the vernier scale coincide with the line at the up of the roller scale. So you just simply count the number of lines of the vernier scale in order to determine the reading of the reading of the amount to which this pointer passes 0.3 of the 4.3 centimeter. Okay, so you have 6. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12 lines, no, in the vernier scale that coincide. In the 12 line, this is the line that coincides with the roller scale. So that is how you read the vernier. So how do we what we call read the observed reading? So this is the formula to read the vernier, no? Observed reading is equals to roller scale reading plus vernier scale reading. Okay, so from the illustration in this one, the lower part of the vernier, the observed reading, we know that the pointer 0 here points, it points 4.3. Wapod siya kaabot sa 4.4. So therefore, dili na to reading on. You will not read the 4.4, but you will read the 4.3. But from 4.3, nilapas naman siya gamay. So kanang paglapas niya gamay, mao na nay basahon. It would be read by the vernier scale. So the pointer 0 here only reads the roller scale. But the extra reading can be read by the vernier scale. Okay, so as I've said earlier, that the pointer 0 here reads 4.3. So that's why you have 4.300. Because why we use 3 decimal places? Because the accuracy of the vernier is in 3 decimal places or 1,000th reading. So you have 4.300, no? Because it did not reach 4.4. So lilapas lang siya gamay sa 4.3. So ang extra na reading will be read by the vernier. So what is the extra reading? The extra reading here is 12 lines. Mao na to, that is the one read by the vernier, which is the 12 line, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's why you have 12 lines. So you multiply that by the scale, no? That in every line of the vernier scale, equivalent na siya of 0.005 cm. So that's why 12 lines multiplied by 0.005 cm per line, then the reading here is 0.06 cm. Cancel the lines. So what is now therefore the observed reading of the vernier caliper. So you add the ruler reading, which is 4.300 plus the what? The vernier reading, no? The vernier reading. So therefore, what is the total reading? So the observed reading, therefore, in this condition is 4.360 centimeter. Meaning to say that the extra reading beyond 4.3 is 0.06 centimeter. So that is how accurate is vernier caliper. It reads in 3 decimal places. Okay? So, as I've said, you can also use the vernier caliper using the English system. No? So, in the English system, which is in the upper portion, the roller scale is in inches. You have here 2 inches, 3 inches, and so on and so forth. You start from 0. And the vernier scale is divided into 8 lines. So 1, 2, 3, 4, 5, 6, 7, 8. Unlike sa metric, divided into 20 lines. So sa English, it is divided, the vernier scale is divided into 8 lines. And each line is 1/128 of an inch. Okay? So the same procedure, when you read that, the 0 in the vernier caliper here is the pointer. So it points the reading on the ruler scale. Okay? So we know that from 1 inch to 2 inches, there are 16 lines. No? 16 lines. It is divided into 16 lines. And each line is 1/16. Okay? Each line is equals to 1/16. So in this case, this 0 points on how many lines? Gikan sa 1. Since this is 2, so 16 man, so 16, 15, 14, 13, 12, and this is 11, no? 11. So because this is 16, this is 15, this is 14, this is 13, 12, 11. Wakod siya maabot sa 12, nara siya sa 11. So therefore, you will have, the reading here is 1 inch and 11/16, no? 11/16. That is the reading now. 1 inch and 11/16. Okay, so this is the reading. 1 inch and 11/16 inch. So this is now the ruler reading, no, using the pointer 0. Now, however, nilapas, dunay paglapas gikan sa ka-11. So ang nilapas, the extra reading here can be read using the vernier, no, scale. So the same procedure, you will find the coincident line, no? Asa man ang coincidence line, meaning to say ang linya sa ruler scale ug ang linya sa vernier scale magtungod, they will be in one line. So kung if we try to find the coincidence, ang coincidence kanang tungod diha sa kire 1, 2, 3, ikatulo nga linya sa vernier. So this is the coincidence. So therefore, pila ang coincidence? 3 lines. So since one line is equivalent to 1/128 inch per line, so therefore this is now the extra reading. No, mao ni ang extra reading. This is the ruler reading. So this is 1 and 11/16 inches plus 3/128 because you multiply this, so what? 3/. So first you change this. This is a mixed number. you change this into an improper fraction. Improper meaning dako ang numerator kaysa denominator. So 16 times 1, 16 plus 11, that would be 27 over 16. This one here is 128 over 3. So kung imong tan-awon dili pareha og denominator, so we'll find the common denominator. So let's say 128. So the common denominator is 128. So 128 divided by 16, that is 8, no? So if we try to use the calculator, divided by 16, that is 8. So 8 times 27, that is 216, no? 216. So because you have the common denominator is 128. 128 divided by 16 is 8. 8 times 27 is 216. Okay, then 128 divided by 128, that is 1 times 3, that is 3. So you add, that would be 219 over 219 inches over 128. So you divide that, no? You divide 219 by 128. So it comes up that the reading is 1.711 open ends. So 3 decimal places. The reading now is 1.711 open ends. Okay, so this is how you read the vernier caliper in the English system, and this is in the metric system. Okay, so we will now proceed to our experiment, no? The experiment number 2, which is vernier calipers. Okay.